All right, 8th graders, this is your practice test to help you prepare for Friday's real test. So follow along, take notes, make sure you're doing everything the way that I'm modeling it, and then you'll be fine for the test on Friday. So let's take a look at the practice. Okay, so here's our first problem. So if you take a look at the top of each of your sections, it tells you what it is that you're doing. And so this will just remind you that this is the skill for this week. We've been factoring simple polynomials, okay? And so let's take our polynomial, number 1, and I know that it's going to become a binomial times a binomial. So I'm going to go ahead and put my binomial terms. I'm going to do all the things that I know first. I know that my first term, that x squared, is made by my two first terms. So I'm going to put two x's there. I know that my last term is made by my last two terms here and here in my binomials are made from this last term here. But this one has that variable on it. So I'm going to throw in my y's and I'll deal with my numbers in a minute. Okay, I'm going to make my chart, which says that I have to multiply to make a 42 and I have to add to make a negative 23. Okay, but let's check our signs. If it wants to multiply to make a positive and add to make a negative, I know that the only way to multiply to make a positive is a positive times a positive or a negative times a negative. Well, a positive times a positive will never add to make a negative, so it must be two negatives. So I'm going to put my negatives in here. Okay, now I'm going to go to my factors. 42 has the factors of 1 and 42, 2 and 21, and look, 2 and 21 will add to make a 23. So I'm going to go ahead and put my 2 and my 21 into my problem. And now I'm just going to check it just to make sure it works. So I'm going to say that x times x, which is my distribution piece, right? X times x is x squared, and then x times negative 21y is negative 21xy. Now I'm going to do my next distribution for this second term. Negative 2y times an x is negative 2xy, and a negative 2y times a negative 21y is going to give me a positive 42y squared. And when I combine my middle terms, these guys here, I end up with a negative 23xy, because 2 plus 21 is 23, both negatives, plus a 42y squared. Now, is this what I started with? It is, which means that I can go ahead and box this as my final answer. Okay, now let's move over to problem number 2. I'm going to give us a little more space to work. And I'm going to say that we need to start with our binomials. We know that this is going to be two binomials times each other. I know I'm going to need a chart that shows me that I'm multiplying to make a positive 60 and I'm adding to make a negative 27. Okay, my first term. Oh, look, this is interesting. I have a 3 as my A. Well, I might need to do a little erasing because I started a little bit early thinking I was going to do binomial times binomial. However, I've got a 3 as my first term, which means that I probably can factor something out. So I'm going to take these guys to their primes. 3 times x minus 27 is really 3 times 9 times x plus 60, which is really 3 times 20. And it looks like I have a 3 that can come out of everything. So if I factor out my 3, I'm really dividing by a 3. I'm going to pull it to the front. I'm left with an x squared minus a 9x plus a 20. Okay, now I can take this to binomials, but I'm going to make my new chart, which says that I'm multiplying to make a 20 and I'm adding to make a negative 9. Okay, so I'm going to leave my 3 out in the front. I'm going to make my two binomials. My first term is that x squared, so I know my x's go here. I'm going to think about the signs now. multiplies to make a positive, adds to make a negative. Must be a negative and a negative, because a negative times a negative will multiply to make a positive. Now for our numbers. 20, the factors of 20 are 1 and 20, 2 and 10, and 4 and 5. Okay? Which guys will add to make negative 9? If they're both negatives, will they make a negative 9 when added? 1 and 21 will not. 2 and 10 will not. 4 and 5 will, which means that my 4 goes in one and my 5 goes in the other. Okay, now before I box my answer, I really want to check and make sure it's right. So I'm going to FOIL it back out. I'm going to leave my 3 alone for a minute, and I'm going to do my distribution. X times x is x squared, and x times negative 5 is negative 5x. Then we have a negative 4 times an x, which is a negative 4x. And I have a negative 4 times a negative 5, which is a positive 20. And now I'm going to simplify by combining my middle terms. Negative 5x and negative 4x make a negative 9x plus 20. Now I'm going to distribute my 3. So I get 3x squared minus 3 times 9 is 27x plus 3 times 20, which is 60. And this actually matches my first starting equation up here. So I'm good, which means I'm going to take the time to box my final answer. Okay? Now let's move on. Let's go to problem number 3. This one is adding and subtracting. So again, take a look at the title of your section so you can just double check what you're supposed to be doing. Okay? Now when I'm adding and subtracting, I almost always write them on top of each other. Okay, you can distribute the negative, but what happens is you guys sometimes you forget that you actually have to distribute that negative. So when you're dealing with subtraction, remember that you change it to addition and change the power. Well, that negative 1 has to be distributed through. So you really get a negative 2x, a positive 5x, and a negative 2. So I'm going to rewrite it, make sure that I have all my ducks in a row and don't lose anything. So I'm going to have 6x squared minus 9x minus 4 plus a negative 2x squared plus a 5x plus a negative 2. Okay, and I'm just going to switch all my negatives to adding the opposite. And now I'm going to combine like terms. I have x squares. I have a positive 6 and a negative 2, which makes a 4x squared. Now I have x's. I have a negative 9x and I have a positive 5x, which when combined makes a negative 4x. And I have a positive 4 and a negative 2, which combine to make a positive 2. Okay, and this is simplified. Okay, you don't have to take it any further. Next week, we'll be adding and subtracting polynomials, and once you get them to this step, then we'll be factoring them out and graphing them. But right now, because it only says simplify and show all your work, that's all you have to do. All right, moving on. We're going to do a multiplication piece. This is the foiling. Okay, so we're going to be distributing, double distribution. So 4x times 2x is 8x squared. And 4x times a negative 3 is a negative 12x. 1 times 2x is a positive 2x. And 1 times negative 3 is a negative 3. So I'm going to combine my like terms, which are those center terms. So I'm leaving my 8x squared alone. A negative 12 and a positive 2 make a negative 10x. And I have a minus 3. And this is my final answer. Okay, so now I have another page. Our last problem. Our last problem is to graph. Okay, now the best way to graph is to put things in y equals mx plus b. So this first problem, this first problem up here, he's in y equals mx plus b. He's y is greater than 2x minus 4. Okay, so I'm going to graph him with red. because then I'll be able to tell my lines apart. Okay, and so his intercept is a negative 4. So I'm going to find negative 4, 1, 2, 3, 4, somewhere right around there. Okay, and his slope is 2 over 1. It's positive. Positive slopes go up and to the right. So I want to make sure that I count up and run 1 in a positive direction. Up 1, 2 over 1. Up 1, 2 over 1. Up 1, 2 over 1. Okay, and so the next thing I have to do is I have to decide if my line is supposed to be dotted or solid. Well, because this is a greater than symbol, I'm going to make it dotted. It's not equal to, so therefore he needs a dotted line. Okay, and if I really hadn't used colors or something like that, I should label this guy. So I'm going to call this red guy y is greater than 2x minus 4. Okay, and now I'm going to get a different color so that I can do my, oh, I forgot to shade him. We need to shade him. Y is greater than. Where is y greater? So in this, if you look at the instructions really carefully, it says check a point to verify solution. Okay, so I'm going to check a point for my shading first. Okay, and my shading needs to go up. So I'm going to check this point right here, 0, 0. If I plug in 0, 0 to this problem, I get 0 is greater than 2 times 0 minus 4. 0 is greater than negative 4. Is that true? Yes. Which means that this problem needs to be shaded in this upward direction. Okay? Or this line needs to be shaded in the upward direction. But now we have to deal with our other line. So I'm going to take the equation of my other line that they gave me, and I'm going to use another color so that I can keep them separate. And I'm going to convert it to y equals mx plus b so I can graph it really easily. So I'm going to say that I need to add 2x to both sides, and I get negative 3y is greater than 2x minus 3. And now I'm going to divide by a negative 3 for each piece so that I can get my y alone. So y, and now because I divided by a negative, I have to switch my sign, is equal, or y is less than 2/3 negative x plus 1. So I have a plus 1 intercept, which is here. Okay, and I have a negative slope, which means I'm going down and to the right. And so I have to go down 2 and over 3. 1, 2, over 1, 2, 3. Okay, and my lines have just crossed. So guess what? I don't need to make any more. But I do need to know if my line is solid or dotted, and it's dotted because this is a less than symbol. So we have our dotted line. And of course I'm going to label my line, because we always need to tell the reader of the graph which line you graphed where. Okay, and now we need to shade it. Y is less than. So I'm going to check that 0, 0 point because it's not on the line. So I'm going to check it again and say, if I have 0 here and I have 0 here, I really end up with 0 is less than plus 1. Is that true? Yes. Which means that I'm going to shade in the direction of that 0, 0. So now I have to make sure that I know what my solution is. So I'm going to choose another color, and I'm going to shade the joined area. Well, the joined area does not include the line. It includes everything up until the line. And it goes all the way to this red line over here. Okay, and this should be my solution area in here. And you don't have to be completely perfect about your shading, but the idea is make it darker, make it visible. But remember, check a point to verify solution. So we need to make sure that we plug in a point to verify that is a solution, or that is the correct shaded area. So I'm going to pick a point way over here. Okay? It doesn't actually matter what it is. A point that's way over there is going to be a negative x value, and I can choose y is 0 because that x-axis is running through there. So let's plug in a point. And when we check this point, we have to check it in both equations. So I'm going to choose the point negative 10, 0 to do as my check. And so I have y is greater than 2x minus 4, and I'm going to plug in this point. 0 is greater than 2 times negative 10 minus 4. 0 is greater than negative 20 minus 4. 0 is greater than negative 24. Is that true? Yes. So check. I worked on that line. Now I'm going to do it in this other equation. So this second line I have to check it in. So I'm going to plug it in again into my other equation. And so this time I'm going to plug it into this guy right here. Okay, so I'm going to say negative 2x minus 3y is greater than negative 3. Okay, sorry, my pen got a little crazy. So negative 2 times a negative 10 minus 3 times 0 is greater than negative 3. Sorry, guys. I get a positive 20 minus 0 is greater than negative 3. So 20 is greater than negative 3. Is that true? Yes, it is true. And therefore, this point is a solution to both of those lines, so I have shaded in the correct area. All right, this is the end of your worksheet for today. So good luck on the test tomorrow.